The National Electrical Code, or NEC, allows for the splitting of a single service entrance conductor into multiple conductors under certain conditions. Article 230.40c states that where multiple service entrance conductors supply a single phase, three-wire, or phase-to-phase service, they shall be considered as one service entrance conductor. Consider an installation with a 1600 amp substation breaker with 4 sets of 500 kc mil conductors feeding 2 separate 800 amp fuse switches. 2 sets of 500 kc mil conductors feed switch 1 and 2 sets of 500 kc mil conductors feed switch 2 from the 1600 amp breaker directly. Both switches are fused at 800 amps. It is acceptable to split the service entrance conductors into 2 sets each and feed 2 separate loads directly from the upstream breaker. In this case, there are 2 sets of 500 kc mil conductors feeding 2 separate 800 amp fuse switches. Each set of 500 kc mil conductors is considered one service entrance conductor. Therefore, it is permissible to split the service entrance conductors into 2 sets and feed 2 separate loads directly from the upstream breaker, in accordance with the NEC. Note that the fuse switches must be rated for the full amperage of the service entrance conductors. In this case, the fuse switches are rated for 800 amps, which is the same amperage as the service entrance conductors, satisfying this requirement. Understanding the NEC requirements is crucial for safe and compliant electrical installations. The NEC provides detailed guidelines for various aspects of electrical systems, including service entrances, conductor sizing, overcurrent protection, and grounding. It is essential to consult the latest edition of the NEC and applicable local codes to ensure that all electrical work meets the required standards. When dealing with service entrance conductors, it is important to consider factors such as ampacity, voltage drop, and conductor insulation. The ampacity of a conductor is the maximum current it can carry continuously without exceeding its temperature rating. Voltage drop is the reduction in voltage along the length of a conductor due to its resistance. Conductor insulation is the material that surrounds the conductor and prevents it from coming into contact with other conductors or grounded surfaces. Proper conductor sizing is essential for ensuring that the electrical system can safely and reliably carry the intended load. Undersized conductors can overheat and potentially cause a fire, while oversized conductors can be unnecessarily expensive. The NEC provides tables and guidelines for determining the appropriate conductor size based on the ampacity, voltage drop, and other factors. Overcurrent protection devices, such as fuses and circuit breakers, are designed to protect electrical circuits from overloads and short circuits. These devices interrupt the flow of current when it exceeds a predetermined level, preventing damage to equipment and reducing the risk of fire. Grounding is the process of connecting electrical equipment and systems to the earth, providing a path for fault current to flow back to the source. Grounding helps to protect people from electric shock and reduces the risk of fire. The NEC provides detailed requirements for grounding electrical systems, including the size and type of grounding conductors, the location of grounding electrodes, and the bonding of metallic components. It is important to follow these requirements carefully to ensure that the electrical system is properly grounded. In addition to the specific requirements for service entrance conductors, the NEC also contains general requirements for electrical safety. These requirements cover topics such as working space around electrical equipment, guarding of live parts, and the use of personal protective equipment. Electrical work should only be performed by qualified and licensed electricians who have the necessary training and experience. Working with electricity can be dangerous, and it is important to take all necessary precautions to avoid electric shock and other hazards. Before starting any electrical work, it is essential to energize the circuit and verify that it is not energized using a voltage tester. All tools and equipment should be in good working order and properly insulated. Personal protective equipment, such as rubber gloves and safety glasses, should be worn as needed. It is also important to be aware of the potential hazards of arc flash, which is a dangerous electrical explosion that can occur when working on energized equipment. Arc flash can cause severe burns, blindness, and even death. To protect against arc flash, electricians should wear appropriate arc-rated clothing and use insulated tools. In summary, the NEC allows for the splitting of a single service entrance conductor into multiple conductors under certain conditions, as specified in Article 230.40c. The fuse switches must be rated for the full amperage of the service entrance conductors, and all applicable NEC requirements must be followed. Electrical work should only be performed by qualified and licensed electricians who have the necessary training and experience to ensure safety and compliance with all applicable codes and standards. Understanding the relevant NEC articles and applying them correctly is vital for ensuring a safe and reliable electrical installation. The correct application of these standards prevents potential hazards and ensures the longevity and efficiency of the electrical system. Always consult the latest edition of the NEC and any local amendments to ensure compliance with the most current regulations. When dealing with complex electrical installations, it is advisable to seek guidance from experienced electrical engineers or consultants who can provide expert advice and ensure that the system is designed and installed in accordance with all applicable codes and standards. Consider voltage drop. Voltage drop is the reduction in voltage that occurs along the length of a conductor due to its resistance. Excessive voltage drop can cause equipment to malfunction or operate inefficiently. The NEC recommends limiting voltage drop to no more than 3% for branch circuits and 5% for feeders. To minimize voltage drop, use larger conductors or reduce the length of the circuit. Also consider ambient temperature. The ampacity of a conductor is affected by the ambient temperature in which it is installed. The NEC provides correction factors for adjusting the ampacity of conductors based on ambient temperature. If a conductor is installed in a high-temperature environment, its ampacity must be reduced to prevent it from overheating. Additionally, consider derating factors. The NEC requires that conductors be derated when multiple current-carrying conductors are installed in a raceway or cable. This is because the heat generated by the conductors can raise the temperature inside the raceway or cable, reducing the ampacity of the conductors. The NEC provides derating factors for different numbers of conductors in a raceway or cable. The NEC also addresses the separation of service entrance conductors from other conductors. Service entrance conductors must be separated from other conductors to prevent accidental contact and to minimize the risk of fire. The NEC specifies the minimum separation distances for service entrance conductors from other conductors, as well as from grounded surfaces. The NEC includes requirements for the identification of service entrance conductors. Service entrance conductors must be identified by color coding or other means to indicate their voltage and function. This helps to prevent accidental contact with energized conductors and to ensure that the electrical system is properly wired. The NEC also requires that service entrance conductors be protected from physical damage. Service entrance conductors must be installed in raceways or other enclosures to protect them from abrasion, impact, and other forms of physical damage. The type of raceway or enclosure must be appropriate for the environment in which the conductors are installed. The NEC provides guidelines for selecting the appropriate type of raceway or enclosure for different applications. The NEC addresses the use of surge protection devices for service entrance conductors. Surge protection devices are designed to protect electrical equipment from voltage surges caused by lightning or other events. The NEC recommends the use of surge protection devices for service entrance conductors, especially in areas that are prone to lightning strikes. In conclusion, understanding and applying the NEC requirements for service entrance conductors is essential for ensuring a safe, reliable, and compliant electrical installation. Attention to detail in design, installation, and maintenance is critical for preventing hazards and ensuring the long-term performance of the electrical system. Consulting with qualified electrical professionals and staying up to date on the latest NEC revisions are essential for maintaining a high level of electrical safety and compliance. When working with electrical systems, always prioritize safety and follow all applicable codes and standards. Remember that electricity can be dangerous, and it is important to take all necessary precautions to avoid electric shock and other hazards. By following these guidelines, you can help to ensure that your electrical system is safe, reliable, and compliant with all applicable codes and standards.